Hello everyone, in this video we are going to be doing an overview of SQS FIFO queues. Now FIFO queues offer a number of advantages over standard queues, and I want to take some time to show you what they do, how they work, and then show you an example of them both on the whiteboard and in the AWS console. So that's the agenda for this video. And I do want to point out that this video does have an assumption that you're already familiar with basic SQS standard queues. If you're not, you may want to watch a video of mine that I'll put in the description that does a great high-level overview just as a beginner guide to SQS. Again, that'll be in the description section of this video. So let's just jump right into it. And at first, I want to talk about some of the advantages that SQS FIFO queues offer over standard queues. And it turns out that there's two main advantages that FIFO queues give over standard. The first one is that FIFO queues offer guaranteed in-order processing. So what that means is that when you put a message into a queue or a sequence of messages, say message 1, message 2, message 3, you are always going to receive those messages when you attempt to process them in the exact same order that you put them in. So you'll receive message 1 first, then message 2, then message 3. This is not guaranteed with standard queues. They do attempt to preserve order, but there's no guarantee that this may occur. So you may get message 3 first, then message 1, then message 2. The second main advantage that SQS FIFO queues offer is that they prevent duplicate messages. So this can occur in many different scenarios. The first one on the publisher side. So if you're in your application, you publish a message and then maybe some error occurs and you attempt to retry, but you retry too many times and you publish that message again, you will now have two messages in your queue. Now you may be asking yourself, like, is that a big deal? Well, it kind of depends, because if you have something like an e-commerce application where every message signifies an order, you obviously don't want to be placing two distinct orders for one order that was paid for. You always want to ensure that it's a one-to-one mapping. So FIFO queues prevent this situation from occurring using a concept called content deduplication, and they also ensure that on the SQS side, in case there's any kind of partition failures on the SQS service itself, it will also not introduce any duplicate messages, which is an extremely rare occurrence with standard queues, but you are also protected from it. So those are the two key advantages of using SQS FIFO over standard. And I just want to take a second to pause there and just kind of do a check here. Like, what's the so what here? Why is this important? And should you be using SQS FIFO queues in the first place over standard queues? Well, as I kind of alluded to before, the answer is, like, it kind of depends. But there are many different applications that require in-order processing. In-order processing is really the big one. Message deduplication is another benefit, but if you're using FIFO, it's probably because you want in-order processing, as the name suggests. So what are some examples where FIFO is a useful concept in like different application types? So the first one is, consider that maybe there's an airline ticketing system that exists. And in any standard airline ticketing system, first you pay for your ticket, then you select your seat, then you kind of decide if you want to have a carry-on or a baggage or whatever, and then you're finally done. So in this example, if you're using messages to process these things in sequence, you certainly do not want to give the user the ability to select a seat before they purchase successfully the ticket. That wouldn't make any sense. So that's a use case where, this type of in-order processing can potentially be important. Another one, consider you have a system that does GPS location-based tracking on some kind of UI or something like that. And it's constantly pinging some devices for the most recent location. You don't necessarily want to show out-of-order pings, because that would kind of suggests that the user is jumping around in the physical space, and you want it to be, in order sequenced. He's at this spot, then he's at this spot, then he's at the next spot. So that's another use case where in-order processing can be important. And another really relatable one is for e-commerce applications. So in any e-commerce applications, first you pay for the thing, then the company kind of puts it in a package, then they send it off, and then it finally gets marked as delivered. You want these things to occur in a particular sequence. You don't want to ship or pack a package before they've paid for it, kind of similar to the airline ticketing system. So these are some examples where in-order processing through the use of FIFO queues may be important and something that gives you an idea of how they can be used in real life. All right, so that's the kind of so what of using FIFO queues. Now let's talk about a little bit more about this service and some of the key concepts that you want to know about when you are working with FIFO queues. So the first one in the area of deduplication. So for deduplication, as I mentioned before, this feature allows you to prevent messages from being introduced, duplicate messages that is, from being introduced into your queue. So you do have two options when it comes to using deduplication. Using the first method, which is optional, you can configure this onto your queue if you wish, but this method is called content-based hashing. And what this means, if you enable it, is that messages that have the same content or the same payload inside of their body are discarded. That is if you happen to send the same message within a 5-minute interval of the first message. So if you send the first message and then within 5 minutes, you send an identical message with the exact same payload inside the body, the second one will be discarded. Your operation to send the message into the queue will succeed, but the message will not actually be sent into the queue. It'll automatically be detected and thrown away by the SQS service. So this is an optional method that you can use. It's kind of an implicit deduplication method. The other one that is more explicit is something called a message deduplication ID that you can provide when you publish a message into your queue. And this means that messages with the same provided ID are discarded. So if they have, 1 or 2, whatever the ID that you choose to pick for your unique message, same rule applies. If you send it again within 5 minutes, it's going to be discarded. So two methods that are at your disposal. You can actually use both of them and interleave them, but it's a little bit more complicated. I would suggest using either just one or the other, but they are at your disposal. Now, the second main concept that is kind of the bread and butter of FIFO queues, the really important and powerful concept, is this concept of message grouping. So message grouping allows you to label messages with a specific ID, and it ensures that messages with the same ID are always processed in the exact same order. So let's take that e-commerce application again, right? Like assume we have a queue like we have one here. We have many different customers, and many different customers are placing many different orders, right? And we already established that we want to process messages in the same sequence in which they are put into the queue, but for every unique customer. So customer one's orders are always going to be pulled off of the queue in the order in which they are put into the queue. Similarly, for customer two, the same concept applies. We always want the order to be preserved, but at a customer level. And this is what grouping allows you to do. So within your queue, you can set a group ID on the message when you publish it into your queue. And this will ensure that, as you can see in this case, for example, customer one, the messages for customer one will always be processed in sequence. And separately, the messages for customer two will always be processed in sequence. There's no limit on the number of groups that you can have. And this is actually how SQS FIFO achieves really high level of scale by using partitioning on the message group IDs. But this is a really powerful concept that is really useful in a whole bunch of different applications. So that's a really important one to be aware of. All right, so these are the two key concepts that you need to know about when you're working with SQS FIFO queues. Let's talk about a couple examples now. So the first one is kind of a simple one, and this is our FIFO queue here. The left-hand side is our tail, and the right-hand side is our front. So if you put messages in, they're going to show up first on the right. And this example is going to be if you're using a single group ID. By the way, that grouping mechanism, you always need to provide a group ID, but you can choose to just use a fixed group ID if you want, if you just don't want that kind of separation based on customer in that example. This will have some implications on how much you can scale with your FIFO queue, but it is kind of a reasonable use case for a lot of different users of SQS FIFO. All right, so in this example, let's assume that we are publishing messages into our queue. So first we put A1, then we put A2, then we put A3. So when you are processing messages from your queue, you can do so using different batch sizes. So you can either read one message at a time, 2 messages at a time, 3 messages at a time, all the way up to 10 messages at a time. So in this case, when we're just working with a single group ID, it's pretty straightforward. Like if you're reading just one message at a time, then what's going to happen? Well, the first message is going to be A1, the second one is going to be A2, and then the third one is going to be A3, right? So you're going to get get them in sequence on every single request. What happens when you have 2 messages at a time? You're receiving 2 in a single request. Then it becomes, you're getting these 2 messages at once. So that's going to be in your first request. And then your second request is going to be A3. You're never going to get like A1 and A3. That is guaranteed from the SQS service. So that's how it works for a very trivial example, just using a single group ID. And just to demonstrate that concept of deduplication, if you're using content-based deduplication in this case, say we didn't process any messages in this queue yet, they're all here. If you try to put in A3 within 5 minutes of putting the initial A3 into the queue, so this is your second attempt within 5 minutes to insert A3 into this SQS FIFO queue, then this is going to fail. You're not going to be able to put that message in. It's going to be discarded on your behalf from the SQS service. All right, so that's an example for just a single group ID. Let's move on now to talk about a little bit more of an interesting example that uses 2 different groups. So this uses like the customer A and customer B in this case, or group A and group B rather. So say we have something kind of similar. So we have, A1 coming in that we put into the queue, then we put in B1, then we put in A2, then we put in B2, then we put in A3, then we put in B3, right? So this is the sequence in which we put messages into our queue. So what is the potential sequence of messages that we're going to get when we attempt to read from our queue? So this kind of works in a way that you may not necessarily expect. When you're working with groups, you can get like different results depending on the request. So it's seemingly random. So say we're reading like one message at a time here, right? So one message. The first message that you're going to get is going to be either A1 or B1, right? So you'll get A1 or B1 because they are at the front, right? The front of this queue. And then say, for example, in this case, we got A1, right? So that was what we received first. Then in the next attempt, we are either going to get A2 or B1, right? You're still in sequence according to the groups, but not necessarily in the order in which these messages arrive because B1 came before A2. So you may get A2 here, and then same kind of thing applies. In the next attempt, you're either going to get B1 or A3. Say you get this, right? You got A3. Now there's nothing left for A, so you're going to get B1, then you're going to get B2, then you're going to get B3, all right? So this is a pretty simple example. When you're reading one message at a time, it's a little bit random, but it kind of makes sense if you think about it. All right, so let's do this again now. And let's say that there's 2 messages. So 2 messages in the group. What is that going to look like? So this one, it's a pretty simple formula. You are either going to get A1 and A2 like this, or B1 and B2 like this. So you're going to get one of those 2 options when you read with 2 messages from your batch. Now with 3, it's pretty much the same story. So with 3, you're going to get basically this group here. So all of the A's or all of the B's, right? Now with 4, it's a little bit interesting because now 4 kind of exceeds how many we have in one particular group because, in this top group here in the A's, we have 3, and this bottom group with the B's, we have 3's as well. So what is the sequence and what are we going to get back in our request? So there's 2 options. The first one is this. So you're going to get all of the A's and 1 B, or the inverse. So all of the B's, and 1A. Those are the 2 options that you'll get back. So that's how it works for 4. And then with 6, obviously it's everything at once. So with 6, it's all of this stuff in sequence. So you'll get A1, B1, A2, B2, A3, B3. So that will be the order of the items in your list. All right, so that is it for the example here. I do want to talk about one more quick little section just in terms of limits, because I do think it is worth noting how the limits work with SQS FIFO. So the first one is for the default case. So if you use just a single group ID, either by hard coding one, actually, I guess by just using like a fixed group ID that you put for every single message, then you're limited to 300 calls per second per API. If you read 10 messages at a time or you perform 10 messages at a time, you can get up to 300 calls per second with batching, okay? So that's the limit that is going to be enforced for you. You're going to get throttling errors if you try to go above that. That's not really where the main power comes from using SQS and FIFO. Where the main power comes is when you use the second mode, which is, they call it high throughput mode, which is the recommended mode. And the implications for this is it's kind of region dependent. So in the most popular regions, which are US East 1, US West 2, and EU West 1, I believe, you'll get the numbers that I'm about to show you, but it's slightly smaller in some of the other less popular regions. So for those regions, you can get up to 6,000 calls per second per API or 60,000 with batching. And the way that it achieves this is that it auto scales your partitions, but it requires the use of message groups. So it will add additional partitions for different message groups as the throughput goes up or down. If it goes down, it'll reduce the allocated infrastructure, but all of this is handled for you. So this is really where the power of SQS and FIFO comes into play. You can request to increase these limits as well, by the way, but that's something that you'll have to file a support ticket for in order to get them to do that. Now, one other thing that I wanted to point out in terms of limits, it's not really a technical limit, but just kind of a caveat when you're using FIFO queues, which is that if you tend to use SNS and SQS, well, you can't use SNS to SQS FIFO. It is not supported. In order to get delivery through SNS to an SQS FIFO queue, you must use SNS FIFO as the delivery source. So that's one little caveat that you should be aware of. You can't use SQS FIFO unless you have SNS FIFO also enabled. Another thing that I want to say is that you can also not upgrade from a standard queue to a FIFO queue. You must create a new one. So that is the only choice if you want to change between the types at any point in time. All right, so that is it for kind of the slide deck for FIFO queues. I want to take you into the AWS console now. I'm going to show you how to create a FIFO queue, and then we're going to play around with the example that I just showed you for one customer for customer one for different groups, and then just show you firsthand how it all works and how it all fits together. So I'll see you over in the AWS console. All right, everyone. So here we are in the AWS console. I'm in the SQS section of the console, and I'm going to walk you through now how to create a SQS FIFO queue. Then we're going to publish some messages into the queue and then read off of it in the console here to show you how the ordering works when you're using different groups. So let's do that now. So I'm going to go over on the right here to create queue. We're going to click on that, and you can see here the first question that it asks you is, what is the type of queue that you'd like to create? So you either can create the standard queue or the FIFO queue. So in this case, obviously we like to create the FIFO queue. One thing that you'll note is when you're using FIFO queues, the name of them must end with .FIFO. So that is one constraint. It also allows you to easily identify which ones are FIFO. So let's just call this demo.FIFO. It's going to be our name, and some of these configuration settings will be very familiar. So you have visibility timeout, you have message retention, delay, maximum message size, and receive message wait time. These are all consistent with what you would see if you're working with a standard queue. All right, so here are some of the FIFO queue settings. This is where you can specify some of the interesting details. So you may want to use content-based deduplication, which, kind of as we talked about, allows you to duplicate messages within a 5-minute interval based on the content of those messages themselves. Alternatively, you can use that message deduplication ID. Message deduplication IDs as an option are available by default, but if you want to use content-based deduplication, you must enable it. So let's enable it for this demonstration to show you how it works. And then if you select this option here for high throughput mode, it's going to pre-select some of the options here for you. But let's just take a look at this first before we enable that. So the first one is deduplication scope. So how do you want deduplication to work? Do you want it to work amongst the entire queue, so all messages in the queue, or based on the group? So deduplicate all messages that belong to the same message group. That's an option for you to pick from. And then FIFO throughput limit, you can do it just on on the entire queue, or you can do per message group ID. Per message group ID is going to allow you to achieve the really high levels of performance. So that's typically what I would recommend. And if you see here, when you select this, it's automatically going to fill in, message group as the selected option and per message group ID as the option for throughput limit. So those are kind of the high throughput settings. All right, for encryption, we don't need to mess with that. Access policy, we don't need to mess with that. That's the same as standard. We don't need to mess with anything really. And maybe one little thing that I want to talk about really quick is dead letter queues. Dead letter queues can be useful when you're working with SQS FIFO because if you fail to process a message, so like say you have 3 messages in the queue, like A1, A2, A3, if you fail to process A1, you're never going to get to A2. Because since A1 was not processed, A2 and A3 will never get processed. So using a dead letter queue with maybe 3 receive attempts is a very highly suggested thing to use. And if you're not familiar with dead letter queues, I have another video on this entire thing. So you can watch that video or Google it to learn more about this. All right, so that's it for that. Let's create the queue now. And okay, so we created it. So this is what our queue looks like. If we go back to the homepage for queues, you can now see okay, we have demo.FIFO. It is a FIFO queue. No messages are in here. Nothing's in flight. And we do have content-based deduplication enabled, which is great. Let's mess with this and just try some things out. All right, so let's go ahead and go into this queue and play around with this really quick to show you how FIFO queues work. All right, so let's go to send and receive messages so that we can publish messages into this queue. So we're going to click on that. And so it's asking us for the body, and then we have the group ID that we can specify and also the deduplication ID that we can specify, which is optional in this case. All right, so let's mess around. So let's say message body is, 1 and the group ID is 1. We're going to put that in. We should expect this will work. I'm going to scroll down now, going to go pull for messages, and there you go. So there's the first message. You can see the body is 1. Let's do the same thing again. So I'm going to send this message again. And because we have content-based deduplication on, this should not work. So I'm going to send that message. That's the second time. And let's pull again and see what we get. So you can still actually see that there's only 1 message available in this queue. I can click this multiple times. The ID is not going to change. I can even change this to say maximum receive count, and still there's only 1 message in this queue. I'm just going to stop polling now and just change the edit poll settings back to 1 so we can just see 1 at a time. All right, cool. And let's do another small little experiment here. So let's change the message group ID to something different. Let's say 2. And since we're using a different message group ID, which is one of the settings for content-based deduplication that we enabled since we used high throughput mode, this should work now. So because it's a different group ID, but it has the same content, this should still work. So let's send that again. You can instantly see there are now 2 messages available. And let's change this to 2 so we can look at both of them at once. Pull for messages. There you go. So we got the first one, which is here, 5 receives. That's that one. And then the second one, which is right here. I believe it shows you the group ID here. Yeah, so in group ID when you click on details. All right, so that is looking good. One little trick, by the way, if you try to delete messages through the AWS console, is that if you try it like I'm doing right here, like you select them, this will not work. So you go to delete, you click this, is gonna give you an error. Couldn't delete messages. That's strange. The receipt handle has expired. It's a little bit of a quirk with the AWS console. In order to delete, what you need to do is you need to go to edit poll, set this to a really high number for maximum message count received. So say like 999 in this case. There's obviously not this many messages in my queue. Click on save. Go for poll for messages again, and then you see how we're still polling. Because we're still polling, you are now able to delete these messages. It's just a little weird way that the AWS console works, but you'll see this now does work. There you go. And so we can stop polling, and then just when this stops, yeah, there we go. Let's just put that back to 1. All right, cool. All right, so now what I want to do is walk you through that case that we were looking at on the slide deck. So you have many different group IDs, say 2 different group IDs in this case, and you do like let's actually do it right here actually. So let's say A1, and the group ID for this one is A, so we're going to send this message. And then the second one we send is going to be B1, that's going to be B, just Just one B, please. All right. And then A2 belongs to A. All right. And then B2 belongs to B. So now we have 4 messages in the queue. And then A3 belongs to A. Okay. And then B3 belongs to B. All right. So now we have 6 messages in this queue, right? And we are just polling 1 message at a time, maximum message count. So what would you expect here? Would you expect to get A1 or B1 first? And maybe you want to pause the video and think about it, but I'm going to show you what happens right now. So poll for messages. All right. What do we get? We got A1. Cool. All right. So that kind of makes sense with, we put A1 in first, so you would expect to get A1 back. Let's do it again. Poll for messages. What? We got B1 first, or B1 this time. So this just shows you that the ordering that you receive them is according to the group ID, and it's not necessarily like a global timer in which, what did you put in first, A1 or B1? It's according to the group ID, and it's just gonna serve you up a random message. It's not necessarily deterministic. Every time you do this, it may change. So at this point, I want to show you what happens when you do this with 2 and 3 and 4 messages at a time in a single batch. So let's go back and try that now. Okay, so let's go ahead and try this with 2 now. So let's go to edit poll settings. We're going to change the message count to 2. And again, let's poll for messages and let's see what we get. So this is the most recent one. So 4921. So we got A1. I would expect to get A2 back. That's right. Let's try this again. We may get B1 and B2 back the next time. So let's try that. B1 and B2. So you can see it working as expected here. And again, let's try this with 3. So we should get A1, A2, A3, or B1, B2, and B3. So let's do that. There's the 3 messages. So here's A1, A2, A3, and again, so B1, B2, and B3. Now, this wasn't very surprising, but where it becomes a little bit interesting is when you read or when you request more messages that are currently present for a single group. So say, for example, in this case, we have 3 messages in the A group and 3 messages in the B group. What's going to happen now if we request 4 messages in our batch? Are we going to get A1, A2, A3, and B1? Or are we going to get the other way around? So B1, B2, B3, and A1, or what's going to happen there? So let's try that out really quick. So edit poll settings. We're going to change this to 4. And then let's see what happens. And more importantly too, like what's the sequence? What's the order that they're going to show up here? It should be in the order that we put them in some way, shape, or form. So poll for messages, and let's see. So first we got A1, and then we got B1, because that was the sequence. If you remember that I put the messages into the queue, I did A1, then B1, then A2, then B2, then A3, and then B3. So it's giving us it back in that order. So this one should be A2 and then A3. And let's try that again, and maybe we'll get the inverse this time. So A1, this was actually the same. So it looks like it's giving us the same thing every time now. Yeah, it is. All right, so then let's try this again for 6, and with 6 we should get all of them. So let's just confirm. So A1, B1, A2, B2, A3, and B3. So I hope that shows you a little bit about what the kind of behavior is for when you're polling for messages from a FIFO queue using different groups. And if you enjoyed this video, please like and subscribe, and I will see you in the next one. Thanks so much.